the name of our project is Legal Insights Engine. So we know that accessing all the legal documents and getting some information out of them is really a hectic process because the documents are huge, and also the traditional search methods for this research are time consuming and labor intensive. So to reduce that complexity, we are proposing this project called Legal Insights Engine. So we are using some data engineering techniques and the power of AI to provide a simple solution to get information or insights out of legal or law related data. We are using the concept of knowledge graphs to create a graph out of all the cases and their respective attributes. And we are doing a chatbot on top of this to answer questions out of this data. So here's a demo of our application. This is our home page. Here we can see different types of nodes in our graph and instances of each type of node. We have case, quote, category, and opinion. In the sidebar, we have the definitions of legal terminology and the attributes or properties of each node and the relationships between them. You can also add a new case by navigating to the register case page. Here we auto-populated all the fields for simplicity. So when we click on submit, the case gets appended to the graph with proper relationships. Then we have a search. Generally, we know the keyword search where we enter a word in the search bar and we get results which has that keyword. Then we came up with the concept of semantic search where we have embeddings and we convert our query or question into embeddings and compare that with the embeddings of the documents of our interest to get most similar document or top end documents. But here we have more sophisticated technique where we add knowledge graph into this. Here we not only get the most similar document but also the context around it. In our case, our documents of interest are the majority opinions in all cases. So when we enter our query, we not only find the most similar opinion but also the details or context like the case information, that is the case ID, name, author, or other details around this case. Uh, so we'll take an example for semantic search. So what are my options if I get injured at work in a hazardous job? Let's say I'm searching by this question. So when we click on submit, we get the answer for the possible outcome or the possible situation that could happen in this case. So this answers the question we asked, not solely based on the similar document, but also the all of the case details around it. And below we have an actual case which we can refer to based on the question we asked. And we can click on full case details to see how the graph looks like visually. And this is also called the graph exploration page where we can visually see the graph with its relationships. So when you click on this case and select all of its nodes, you can see how they are connected in the knowledge graph, and you can also see the majority opinion for that case. Then we have graph search. This is basically, it converts natural language queries into cipher query, just like SQL but for Neo4j. So here we give an example. Let's say how many cases do we have in criminal case category. So this generates a cipher query to match all of those nodes that has a criminal case as its category and then does a count of it. So we'll have our answer as we have a total of 72 cases in the criminal case category. So this is graph search. Next, we have analytics where we can view different plots to analyze the relationships between different attributes of our data set. Uh, and this is all of the opinion embeddings in 2D space, how they are spread across. And then this is just a distribution of cases across different categories. Finally, we have the similarity. We know the importance of recommendations. So even in our case, we have case recommendations and graph-based recommendations, which has an advantage over other type of recommendations. So in graph-based recommendations, we can explain why two cases are similar. And in this case, we are using Jaccard similarity. So Jaccard similarity is basically the ratio of count of common nodes by the union of nodes between both cases. Say we are looking for similarity between two cases based on the cases each case cites to. So case C1 cites to 5 cases and case C2 cites to 5 cases, and there are 2 cases in common between them. So the similarity will be 2 by 8, which is 0.25. But if we also want to consider two other factors which are significant for recommending the cases, maybe two cases could be similar because they are from same category or because they belong to same code. So we gave an option to customize the weights for calculating similarity. So I'll take a case ID. And let's say we are trying to find a similar case to this case ID. And we thought point 0.5 for sites 2, and then a point 0.4 and point 0.1 respectively for category and code would be good, because we are assuming code might not be that important at this point. So these are the two similar cases for the above case with a similarity score of 0.5, and we can also find the explainability, like how they are similar to a particular court or to a particular category. So we say both the cases belong to Supreme Court of North Carolina and are also civil cases. Similarly, for a different other case, it is similar to with a score of 0.5. Even this case belongs to Supreme Court of North Carolina and is a civil case. So there's no common sites too between these cases, so we don't find any similarity there. Say if a user wants to see the similar cases based only on category, he wants to say which two cases belong to same category. Maybe we'll have weight 1 for category, and the rest of the weights we can make them 0. And then let's click on submit. We can see that the similarity score is 1, and also we can understand how they both belong to property law cases. So this is similarity.